Welcome to my Python tutorial. To download Python, Google Python download and go to the official python.org website. Navigate to the Downloads button and choose your platform, whether it be Windows, Mac, or other. I am choosing Windows in this tutorial. Choose the latest release. In this case, it's the choice at the top, the Python 3.6.4 release. Choosing new releases sometimes limits which modules can work with the version you have, but is generally better quality, and it is the version for which new modules will be created and existing ones updated. I will be using the executable installer, which you can download and then use to install Python. Choosing from these files is a matter of computer specification, but also the type of download you wish to have. I could have, for example, used the web-based installer instead. Download and wait for the chosen file to finish. If you've chosen the executable and don't know much about Python, you'll want to click the Install Now button. If you have a sense of Python and other programming languages, you can customize your installation further. You can then either navigate to the location you downloaded your Python file and find the IDLE desktop application, or if you have a built-in search bar, you can simply look up IDLE and find the file quickly. If you do not have a search bar, it might be useful to create a shortcut on your desktop. Here is an example of how the IDLE works. You simply type in your code and save to a convenient location. Then you can either hit F5 or go to Run in order to run your program. I'm just going to show you a few features of the IDLE before I move into the tutorial. Here you can see the different types of coloration that this program will automatically do for you in order to make your code more easily readable. Under File, you can create new files, open existing ones, save, and close. Under Edit, you can find the undo and redo buttons, copy and paste options, and many other useful tools to help you when writing and navigating code. All of these options come with shortcut key combinations shown next to their titles. Here are the formatting options under Format. This deals mostly with indentation and the white space of the code. The Run tab will give you the option of opening the IDLE shell, where code is ran, and also to run your program, although I mostly use the F5 shortcut. Options gives you the choice to edit the color, font, and size of the IDLE editor, as well as to use code context. Code context will give you context as to which function loop you are currently in if you are scrolled down past seeing their definitions. The Windows tab shows the zoom height as well as the path and name of the current program. Finally, the Help tab will give you all the information you need on the IDLE as well as general Python documentation to help you with your code. These are comments. Comments are used to keep code well documented and developer friendly. Single-line comments begin with a number sign, whereas multi-line comments begin and end with 3 double quotations. To declare variables, you don't need to state the variable type. Variables can be any type and are interchangeable. So you can see I have an integer type to start, but then I turn it into a string and then list. If you notice the syntax, there are no semicolons, like with many other languages. This is because Python separates statements based on white space, which makes proper formatting crucial in Python. Global variables are variables defined outside of a function. In efficient and ideal code, this is highly undesirable, since there is much more confusion as to which variables are important to what functions. To avoid confusion, they are mostly shared function to function and exist only where necessary. Global variables can still be declared inside loops. Loops, functions, and if statements all end with a colon, and conditional statements don't require parentheses around them. Nested lines of code are separated by a tab, so the program knows exactly what is conditional. For example, the test will run no matter if I equals 9 or not. So you can see here that test is not a part of I equals 9, therefore it will run all 10 times. You should always watch out for differences between setting a variable with a single equal sign and checking a variable with 2 in conditional statements. Here's a list of the conditional Python operators. Equals, does not equal, greater than, less than, greater than or equal to, and less than or equal to. You can also see that there are print statements, which can print information to the cell like we saw with test and print A. This is very useful for keeping track of variables and checking for errors, whether it be logic or syntax. You can also see that there's a built-in method, string, or str, right here, which is converting the integer I into a string so that it can be printed to the shell without errors. Python runs line by line, so functions must be declared before they are called. So def fun local variable must be before fun, this is a local variable. On another note, global variables can still be used inside functions, and if you recall from before, we had declared global variable outside of a function above, so we can now print it inside this function. So as you can see here, we can see that it says this is a global variable and this is a local variable. However, if we want to set a variable called global variable inside this function, the program will now assume that this is actually a local variable and will now instead call this while the global value still remains the same value. So we can see that this remains its local state, whereas the global variable never changes. So how we can actually fix that if we were to want to use the global variable but still change it inside the function is we can uncomment this and we can use global variable. So now we're referring to the global variable. So now I can just comment out this print, and now the global version will actually say that it's local now because it's setting this value here. The variables local, variable, and another local are both local and will only ever exist inside of the function. So if we try to print the local variable, we are going to have an error. Name local variable is not defined. Imports are traditionally done at the beginning of a program, and they add libraries that are necessary for your program to work. A popular example might be the math import, which allows for many more new methods such as POW, which is the one used in this example here, but also many other different methods that will help you with your mathematics in the mathematics of your program. Some modules, like the math import, may come with your IDLE, but most do not. You can either download modules yourself from a developer's website, or you can download a tool such as pip, which will actually help you to download these on your own. It is important to remember that having the fewest modules possible is important when accomplishing your goal because it is the most simple and efficient manner to do so. Having too many imports can make things confusing, so you should only import one if it's practical in the context of the program. And we can just see this one run here. So you can see 2 to the power of 3 here is 8. Here you can see Python's arithmetic operators. This includes addition, subtraction, multiplication, exponents, division, and 2 lesser-known operators, floor division and modulus. Floor division will divide normally and then round the answer down if not already divide evenly. Modulus will give you the remainder of a division. Boolean comparisons make up the foundation of every programming language, or nearly. Every time you see an if statement, you are using a Boolean comparison. If 5 is less than 6, then do this. This example will always be true and is therefore not useful to have, but if A is less than 6, this could be more useful in the context of your program. Comparison statements are essential in nearly every Python program. User input is one way and the simplest way to interact with a program's user. They can type into the prompt, and after pressing enter, this value can be carried into a variable as a string type. This can then be modified, analyzed, and turned into other variable types such as numbers if that is desirable. So here I have a quick program that will take user input, convert it into a number, and make some changes using the arithmetic operators. And then if a is more than 10, then it will print true, otherwise it will print false. So we can see here that depending on what we input, if we input 1, it will be true. If we input, say, -5, oh, sorry, need to restart. If we input -5, you can see that is false. Now we're going to do some work with strings. We're going to get some user input and then check whether or not it's numeric, which will check the string to see if it contains only numbers. If it does, we can convert it to an integer and do a little arithmetic. Here you can see a plus equals to and a multiply equals to, which takes the current variable or number and perform that calculation instead of having to say something like number user input is equal to number user input plus 10. Otherwise, it will take the string, which is not just a number, convert all letters to lowercase, print that string, and then go through the alphabet and tell us how many letters of each, or how many of each letter are in the string, if any. It would also capitalize the letter that is printed during the print to make it look a little nicer. And this is a string method, so we'll see that now. So I just bring this up, and we can put in our input. So you can say hello world, and so we can say that there is one instance of a D, one instance of an E, one instance of an H, 3 instances of L's, 2 instances of O's, 1 of R, and 1 of W. So we can see all the different letters that are recognized throughout the list, despite them being capitals. And then we can also see how it took the letter and made it capital when it printed, and then also told us how many instances there was. So there's a few different string methods used in this program, and it's the .lower, .capitalized, .isNumeric, and .count. And those are all useful examples of string methods that can be used during string manipulation. These are very useful, and many more of them can be found by looking at online Python documentation. Thank you for listening to my presentation.